You know, when most of us hear human rhinovirus, we think one thing, the common cold, right? A bit of a nuisance, but nothing serious. Well, what if that whole idea was just wrong? What if the real story of this virus, both clinically and structurally, is way more complex and honestly, a lot more important? Let's get into the science that completely rewrote the book on human rhinovirus.
So what you're looking at here is the classic icosahedral, non-envelope structure of a human rhinovirus. For decades, this little particle was basically dismissed as a minor league player. But today, we know it's a major driver of severe respiratory disease. It's a story that has been completely flipped on its head, all thanks to molecular science.
Just a quick note before we dive in. All the information we're covering today was compiled using a Gemini deep search. And if you want to go through the scientific literature yourself, you can find a complete list of sources in the Notebook LM document linked right below.
Okay, so here's our game plan. First, we're going to completely rethink this pathogen. Then, we'll dig into its modern identity and see what that means for its real clinical impact. After that, we'll look at the very pragmatic Dutch approach to management. And finally, we'll tackle the big one, the structural challenges that make this virus such a tough nut to crack therapeutically.
So, let's start at the beginning. We need to talk about the old way of thinking. How did we get it wrong for so long? Well, for decades, our understanding was really just a product of the tools we had at the time.
This was pretty much dogma. Human rhinovirus was the nuisance pathogen. It gave you a stuffy nose, it went away on its own, and that was the end of the story. The thinking was that the virus was stuck in the cooler parts of your nose and just couldn't cause any real trouble deeper in the body. But then, molecular diagnostics showed up, and everything, and I mean everything, changed. This wasn't just a minor update, it was a total reclassification that changed the virus's family tree and its entire role in the clinic. Now this is where it gets really fascinating. Look at the shift here. We went from classifying the virus based on its behavior, like how it can't handle stomach acid, to classifying it based on its fundamental genetic blueprint. And this genomic approach showed something wild. Human rhinovirus wasn't its own separate thing at all. Genetically, it's an enterovirus, putting it in the same family as poliovirus. And this table just lays out the consequences of that genetic reclassification perfectly. We now have 3 distinct species, A, B, and C. But the one you really need to pay attention to is Rhinovirus C. See that unique receptor, CDHR3, and look at its culturability. You can't grow it in standard lab cells. This is exactly why it was hiding in plain sight for so long. And, as you can see, it's the one most often linked to more severe disease. I mean, this quote just says it all, doesn't it? For decades, a virus causing about 1/3 of all human rhinovirus infections was totally invisible to classical virology. It's a pretty powerful reminder that you can only see what your tools allow you to see.
So with this new identity, how does that actually change things in the clinic? Well, finding this hidden pathogen and now being able to detect all rhinoviruses with RT-PCR has had absolutely profound consequences.
This is the modern reality of human rhinovirus. It's not just a cold. It's a major cause of lower respiratory tract infections. It's the #1 trigger for asthma flare-ups. And, maybe the most important point on this whole slide, a human rhinovirus infection that causes wheezing in the first year of life is the single biggest predictor for that child developing asthma later on. This isn't just a cold virus, it's a potential starting gun for chronic disease.
And that severity isn't spread out evenly. As this chart clearly shows, while rhinovirus B tends to be milder, species A and especially C are the ones consistently linked to more serious illness, more wheezing, and more hospitalizations. This makes knowing this species clinically very relevant. Okay, so we've established we have a virus with a huge clinical burden. So how do we manage it, particularly here in the Netherlands? Well, this is where we run into a really striking paradox.
And there it is. That's the central challenge. Despite its massive impact on global health, we have 0 specific weapons against human rhinovirus. No approved antivirals, no vaccine. That means management is all about supportive and symptomatic care, which makes having clear, evidence-based guidelines absolutely essential.
The Dutch approach, guided by the Netherlands Huisartsengenootschap, or NHG, is really a masterclass in being pragmatic and in antibiotic stewardship. For acute rhinosinusitis, the framework is step-by-step, and it starts with patient education. But the most critical part is step 4. Antibiotics are a huge no-no, unless very specific criteria are met, like a fever that just won't break after 5 days. This really takes good patient communication to manage expectations.
Now, on the public health side of things, the IIVM recommendations are exactly what you'd expect, and honestly, they're things we're all very familiar with now. Good hand and cough hygiene, proper ventilation, and of course, staying home when you're sick. Simple, foundational advice that really works.
Okay, this is a super important distinction in management. While adults have a whole pharmacy of over-the-counter options for relief, the playbook for young kids is completely different. For children under 6, those multi-symptom cough and cold medicines are basically off-limits because of safety concerns and a real lack of evidence that they even work. The focus shifts entirely to safety, supportive care, and single-agent meds like paracetamol.
So why this therapeutic void? Why, after all these decades of research, do we still not have a specific antiviral or vaccine? Well, the answer is baked right into the fundamental structure of the virus itself and its incredible ability to change.
This brings us right back to the virion structure and this brilliant concept called the canyon hypothesis. The part of the virus that binds to our cells, it's hidden deep inside a narrow trench on its surface. This spot doesn't change much, but our big, bulky antibody molecules can't get in there. All they can attack are the highly variable outer parts that are constantly changing. It's a genius strategy for evading our immune system.
This whole structure is called an icosahedral capsid. Think of it as a super stable, 20-sided protein shell. Its stability, combined with that canyon strategy, makes it incredibly resistant to a lot of therapeutic ideas. Plus, its RNA genome mutates at a ridiculously high rate, so even if we design a drug to target an internal protein, the virus can quickly develop resistance. It's a massive hurdle.
And this really just brings our whole story full circle, doesn't it? The challenges we face in the lab directly mirror the challenges we see in the clinic. RT-PCR was the big breakthrough. It let us finally see the whole picture, getting around the limitations of viral culture, which, as we now know, was completely blind to the entire Rhinovirus C species, because the lab cells were missing the right doorway.
So when you step back, the story of human rhinovirus is really a story about scientific progress. We've gone from seeing it as a simple nuisance to recognizing it for what it is, a complex, diverse family of viruses with a massive clinical footprint. And that entire leap in understanding was made possible by molecular tools.
And that leaves us with the million-dollar question. With over 165 different types out there, and with its brilliant structural defenses, what's it going to take? What kind of scientific breakthrough, whether it's a new vaccine platform or a clever small molecule drug, will finally let us conquer this incredibly common, yet incredibly challenging virus?
And that's our look at human rhinovirus. If you found this insightful, please do subscribe to the channel. We would love to hear your thoughts and answer any questions you have down in the comments below.